Hello and welcome to UnCoined. My name is Michelle. Before we get started, I just wanted to say I don't work for the IOTA Foundation, I don't get paid by them, I am not associated with them, and I'm also not associated with Bitpanda or in fact any exchange or company as such. Having said that, I would really appreciate your help. And you can do this by clicking the like button or subscribing to the channel. As you can see from the presentation title, today we're going to talk about GoShimmer. So what is GoShimmer? Well, it's a research and engineering project from the IOTA Foundation that seeks to evaluate core-to-side concepts by implementing them in a node software. So the goal here is to test the core-to-side components. And if you are into technical aspects and like to program, i.e. have a very strong IT background, you can actually help IOTA a lot by setting up a node in the Pollen testnet. And you can see the description down below for the tutorial and the how to do all these things. And naturally, in order to start programming, you would need to install GoShimmer first, and that's also described in the same tutorial in the description below. On May 26th, an exciting development occurred, namely the implementation of the IOTA Congestion Control Algorithm, or ICCA, into GoShimmer. Now, why is this development particularly important? Well, in most decentralized ledgers, information is relayed across a network through a process called gossiping. And gossiping, just as one would imagine, is namely that participating nodes receive messages from one neighbor and then forward them to another neighbor. And as nodes overload with more messages than can be managed by an individual node, they pass the excess onto other nodes. And the result is essentially a mess and ineffective. And that's when what we call congestion happens. So the network has more traffic than it can accommodate. And without proper congestion management, the networks become oversaturated and fail to operate. So IOTA came up with this 3-layer congestion control algorithm. And the first layer they call the network layer, and that manages the lower layers of internet communication, like the Transmission Control Protocol, or TCP. And that is essentially a communications standard that enables application programs and computing devices to exchange messages over a network. The second layer is the networking layer, and this stores and communicates information. And this layer contains the distributed ledger, or the tangle, and the rate, control, and timestamps are in this layer as well. The final layer is the application layer, and this allows for a host application to run on the message tangle. So anybody can design an application, and users can decide which application to run on their nodes. And these applications will all use the communication layer to broadcast and store data. So why should we care about all of this? Well, distributed ledger technologies have very strict requirements which make congestion control a particularly difficult problem to solve. 3 of the most important requirements are listed here. The first of which is fair access. Since the available network resources are finite, access or throughput has to be restricted in some way. In distributed ledger technology, this is usually guaranteed by restricting access through a quote-unquote scarce resource. The second requirement is attack resistance. Malicious nodes cannot be able to disrupt the network naturally. And the third is consistency. All nodes need to write the same messages to their local ledger. So we can now see why IOTA's congestion control algorithm is absolutely essential, as it helps to maintain these and other strict requirements while simultaneously also making sure that the system remains efficient and effective. Thanks again for joining me today on UnCoined. Again, it would really help me out if you click that like button and subscribe to the channel. See you next time.